Okay, so 6.2 is systems of three equations and three variables and the potentially different ways we can do it. And then we'll talk about the matrices as we go. So if you have three equations and three variables, your goal is to get down to two equations and two variables. And that will you do by using elimination to eliminate the same variable in two different combinations. So let's start with what that looks like. If I'm looking at these two equations, I may notice that by looking at them, what variable looks easy to cancel? Between 2 and 3, it's easy to combine them and z to cancel entirely. So let's say I did 2 plus 3, or two equations added together. I get 3x plus 2y, z is gone, equals 4. So now I have one equation with just x and y. I know from 6.1 that if I have two equations with x and y, I can solve for them, and then I could take those two answers and get z from there. Now I need to use a different combination. So I've already used 2 and 3, so I'm either going to have to use 1 and 3 or 1 and 2. Now if I take 6 times equation 2, I know I have 12x plus 6y minus 6z equals 12, and that will allow me to combine it with equation 1 to get rid of z. The important part is that you get rid of the same variable every time. It could be z, it could be x, it could be y. As long as you choose one and go with it, that's fine. Sometimes some will be easier than others, so usually you can make a good pick. So if I take this 6 times 2, this equation, plus equation 1, I get 3 plus 12 is 15x, 9 plus 6 is 15y, 6z plus negative 6z is 0z, and 3 plus 12 is 15. Now I can really clean this up. These can all be divided by 15 to get x plus y equals 1. So we're going to call the first equation I combined 4 and this one 5. Now that I have two equations in x and y, I can use my skills from last chapter to help me solve for y and x. And then once I have y and x, I can plug in to find z. So in order to get these to line up, I'm going to take negative 2 times equation 5. So that's negative 2x minus 2y is negative 2. And add it to equation 4. Equation 4 is 3x plus 2y equals 4. When I add these together, I get x equals 2. Because the y's are gone. Okay, I have x. I can plug that back in to find y. So 2 plus y equals 1. Subtract 2, you get y is negative 1. Once I have x and y, I can plug back into one of my three originals to get z. So we look at x plus y plus z equals 2. We have 2 plus negative 1 plus z equals 2. That's 1 plus z is 2, which means z is 1. Just like in our previous equations, this is a solution set. It's a point. So it's 2, negative 1, 1 as a solution. X, then y, then z. Alphabetical order. So we're not going to solve the second one, but we can talk about what you should do here. Now, if I'm looking for a variable to eliminate, 2, 4, and 8 are useful. I can combine them. Every time I see a 1, though, I know that it's really easy to turn 1 into anything else. So 1 is usually a really nice one to do first. When I look at the y values, I have 2, 3, and 5. None of them really turn into each other very easily, which means I probably want to avoid using y. So what does it look like if we use x? If I, again, label these 1, 2, and 3. If I do 3 times equation 1, I know that'll allow me to add it to equation 2. That would be negative 3x plus 6y minus 12z equals 18. 3x plus 5y plus 8z equals 13 to get 11y minus 4z is 31. Again, once I've combined 1 and 2, if I'm going to use 1 still, because as 1, I want to do 1 and 3. So I'll do 5 times 1 plus equation 3 here. So this one's 4. That's negative 5x plus 10y minus 20z equals 30. 5x minus 3y plus 2z equals negative 18. When I combine these, I get 7y minus 18z equals 12. That's my equation 5. So from here, I could get solutions between those two equations for y and z, and then plug back in to get x. That's a kind of more complicated one with multiplication, but I think you guys can manage. Just be careful. Now, there's an alternate method for solving systems of equations using matrices. So the matrix method, Gauss-Jordan, we turn any system into a matrix and use what are called row operations in order to simplify the system. First, let's look at how our equations become a matrix. All our coefficients for x, y, and z go in for the matrix, and we put our solutions, our answers, what they're equal to, on the right side in this augmented matrix. Solving matrix systems, you try to get the diagonal all to be 1. Why? Because this is going to be 1x equals some number on the right, 1y equals some number on the right, 1z equals some number on the right, which we would like. What can we do? Because these are equations, we can multiply rows by a number, we can add or subtract rows together, and we can really divide by numbers as well, obviously, if we can multiply. We can also multiply rows by numbers and add it, just like we do before. So what do we call the general steps here for solving? You get the top left to 1 by whatever method you need to. You zero out the rest using the top equation. So that means adding 0 out the rest of the column. So you can add multiples of row 1 to 0 out the rest below it. Then you focus on getting the middle term to 1 and 0 out what's above or below it. Then the bottom term to 1, 0 out what's above or below it. And from there, you should end up with just your numbers, and your answers are simply your first, second, and third solution. Now we're going to do the problem that we did before, just in matrix method. And we'll start it in this video and continue it in the next video. So exact same problem we just had. We solved 3x plus 9y plus 6 equals 3, 2x plus y minus c equals 2, and x plus y plus z equals 2 using matrices. So let's put this in the matrix. 3, 9, 6, 3, 2, 1, negative 1, 2, 1, 1, 1, 2. Okay, so the first goal is to get the top left number to 1. To do that, I'm going to say divide row 1 by 3. It's an equation. I can divide everything by 3. You'll see 1, 3, 2, and 1. Nothing else changes. Now, what I want to do is get the two numbers under this 0, so there's no x's left in the other equations. How do I do this? I can take row 3 minus row 1, and I'm going to change row 3 into that. So row 1 and row 2 are not changing. Row 3 minus row 1, that's 0. 1 minus 3 is negative 2. 1 minus 2, negative 1. 2 minus 1 is 1. For row 2, because it's 2, I need to subtract 2 times row 1. So again, now row 2 is changing, but nothing else is changing in the other two rows. Okay, so 2 minus 2 times 1 is 0. 1 minus 2 times 3, so 1 minus 6 is negative 5. Double this, that's 4. Negative 1 minus 4 is also negative 5. Double 1 is 2. 2 minus 2 is 0. So you see here, I zeroed out that row, or that column on the left. Now I can move to the second column. And we'll continue this in the next video.